Hi everybody, my name is Jesse Neal and today I'm going to talk to you about the effect of bovine herpes virus on mononuclear dendritic cells. While the overarching topic that we'll be talking about is the effect of BHV1 on mononuclear dendritic cells, we're first going to talk about the immune system. Then we'll talk about bovine herpes virus and how they affect each other, new ways to treat BHV1, and my research, results, and conclusions. So what is the immune system comprised of? It has two parts, the innate immune system and the adaptive immune system. The innate immune system is the initial detection of pathogens, and this causes the secondary primed adaptive immune system to give long-term protection to the body. In this case, we're talking about the adaptive immune system, and more specifically, we're talking about mononuclear dendritic cells. Now, mononuclear dendritic cells can both see target cells and warn other mononuclear dendritic cells, or MDCs. So what is bovine herpes virus? BHV1 is an immunosuppressive virus that stops the immune system from being able to fight infection and disease. While most time it's not life-threatening, it affects the growth and value of infected cattle, causing economic loss. So now that we know what bovine herpes virus is and what mononuclear dendritic cells are, we want to see what effect they have on each other. The key word in all of this is immunosuppressive. In other words, BHV1 stops mononuclear dendritic cells from seeing or warning other mononuclear dendritic cells. You might ask, why don't we treat it? The answer to that question is we are, kind of. The most common way of treating BHV1 is by treating with a live virus vaccination. This is the administration of a low virulence virus which will prime the immune system without actually harming the animal. This isn't as great as it sounds because there are several drawbacks. The first thing is the live virus vaccination can actually cause stressed animals to get sick. And worse, it can cause pregnant animals to abort. The worst problem is actually causing viral infection rather than virus protection, which is a threat to herd health and can actually make all of your animals sick. This is where we pull all the pieces of the puzzle together, the effect of bovine herpes virus on mononuclear dendritic cells. By researching the immunosuppressive pathway, as well as the antigens that make up the BHV1 virus, it is possible to create a better vaccine. This would give the benefits of reducing the chance of infection to almost zero, lasting longer vaccines, and no application restrictions. Some of the questions we want to answer are why two similar strains of BHV1 have such different virulences, or why they affect cattle differently. The second question we want to see is what cell surface markers are affected, or how the mononuclear dendritic cell's ability to see is affected. We also want to see how cell signals are influenced, upregulated or downregulated, and this is how mononuclear dendritic cells talk to each other. This is a chart of my simple methods before actually analyzing my cells. First, we're going to collect blood, then we derive dendritic cells from the white blood cells. Then we infect the dendritic cells, and then we analyze with 3 different assays. The advanced methods below were actually used to analyze the cells. First, we used tissue culture infectious dose 50, or TCID50, which was used to determine virulence. Then we used flow cytometry, used to observe cell surface marker expression. And finally, we used PCR, or polymerase chain reaction, to analyze the cytokines produced. While there's a lot going on in these graphs, all we really wanted to see was that our BHV1 was acting like we expected it to. And we really did see that. In the left, we see the highly susceptible cells infected 10 billion cells, while the less susceptible MDDCs were only 100 million cells infected. While there's a lot going on here in the flow cytometry graphs, we also see the general downward trend. This is that the cell surface marker expression is greatly decreased as time goes on when they're exposed to bovine herpes virus. In our final experiment, we look at PCR and how it affects cytokine analysis. Here we see the downregulation of both interleukin-1 and interleukin-6, and again severe downregulation of interleukin-10 and interleukin-12, and the downregulation of interferon gamma. In fact, the only two cytokines that were upregulated were interferon alpha and interferon beta, which help to protect surrounding mononuclear dendritic cells. In conclusion, we can see that one strain of BHV1 has a much more negative effect on mononuclear dendritic cells than the other. The speed at which one downregulates surface marker expression gives it an advantage over the other. An upregulation of interferon alpha and interferon beta in the second strain causes the neighboring cells to become protected from further infection. This limits the spread of infection in the second strain to be at another disadvantage to the first. The final conclusion, and maybe even the most important conclusion, is that the first and more virulent strain's ability to downregulate interferon gamma and interleukin-12 significantly affect its adaptive immune system, and it plays a major role in inducing cell surface markers. Of course, our research is not done. We would like to see further investigation of cytokines, interleukin-1 alpha, interleukin-8, and TNF alpha. This needs to be conducted to help determine mononuclear dendritic cell signaling pathways and how BHV1 affects these pathways. These were the first half of my sources, and these were the second half of my sources. While I know this was not the traditional way of doing these sorts of presentations, please let me know if you have any questions or comments regarding the effect of bovine herpes virus on mononuclear dendritic cells.